Okay, this is graphing exponential functions. Yes, sir. So here we go. First thing we need to know is this little guy right here. Okay, so when we read this, we did all sorts of these things before. The A is the number multiplied times B. B is the base of the exponent. So A times B. If A is positive, the graph goes up. If it's negative, it goes down. If B is bigger than 1, then it's growth. If B is exponential decay, if B is negative, or excuse me, if B is a fraction or a decimal in between 0 and 1, then it's called decay. H, remember H is the little number right here inside the parentheses. So when you add or subtract H, it moves things left or right. And then K is the number that's outside, and you're adding that at the end. And so when you add something at the end, that's the one that is right here, adding something at the end. That makes it go up or down, right? So this little sheet is going to be in your given to you in Teams, and then also the homework. Yep, yes, I read. Okay, so let's do some examples. Let's do some examples. So we're going to skip forward to, oops, wrong button. We got to share a different screen. There we go. Okay, so let's start with this one. And we can zoom in so we can see what is we doing right there. What is we doing? So this is y equals e to the x. You say e, yeah, e. We can do it. It's easy to do. So you go to y equals, clean out whatever's there, doesn't matter. Remember, e is down here, the third one up, right above natural log. And so you have to do second natural log e to the x. Now then, this one doesn't have anything added or subtracted to it, right? Nothing added or subtracted. So the picture looks like this. In fact, every normal graph where the B is, where the base of the graph is bigger than 1, remember E is a decimal number bigger than 1, then it goes up like this. This is called exponential growth. That's exponential growth. So that's what you're going to draw right here. So let's draw it. We've got an asymptote right on this line. And we have the graph looking like this. So I think let's see, did I draw that right? Oh yeah, keeps going up, 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 just like that, right? So we know what the domain is, and we know what the range is, I hope. Remember, this one is going this way forever, and this one is going up forever, up, 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 up. And so the domain is all real numbers. And so the way we say that, what x numbers can I pick? I can pick any negative number, I can pick any positive number, and I can put that x right there, because I can raise e to a positive number, or a positive fraction, or a positive decimal. I can raise e to a negative number. I can raise them all, so no problem. What's the range? Well, the range, there is no graph down below 0. So the range has to be all the numbers that are greater than 0, right? That would be the range. Now, where is it increasing? This is the one that causes people trouble sometimes, but you're telling me the X numbers. What X numbers can I pick that make it go uphill? Well, every single X number is going uphill every single X number. So that's the whole domain. So that would be all of these guys. What's the asymptote? Well, every graph, every exponent graph has an asymptote at 0, unless we slide it up or down. So this one's the base graph. So the asymptote is y equals 0. And there's only one. It's a horizontal asymptote. Here, let's write it HA. We know that it's a horizontal asymptote, y equals 0. And then what are the x-intercepts and the y-intercepts? Well, there is no x-intercept because that's where the asymptote is, right? But the y-intercept is right there. And remember, if I put 0 in, if I say e to the 0, right? Because I want to know the y-intercept is the y-intercept is 0 comma something. Well, if I put 0 on an exponent on anything, the answer is always 1. So this is 0 comma 1. And what's the x-intercept? Well, it ain't got an x-intercept, so we're going to say none. Right? Don't leave it blank. Tell me if you know it doesn't have it. So this graph right here, this graph is the graph of e to the x. It's also the same graph, any positive number. So if I said 2 to the x, the graph would be the same. 4 to the x, the graph is the same. The domain is the same. The range is the same. The asymptotes are the same for any value that's bigger than 1. So I could pick. So if I wanted you to graph, let's say 3 raised to the x, it'd be the same graph. What about 17 raised to the x? It would be the same graph. As long as it's bigger than 1, the graph is going to look like this blue line. It's going to have the same asymptote. It's going to have the same intercepts. So let's look at one that doesn't look the same. Let's look at this one. What's different here? Well, it's a fraction, right? So if you remember that little sheet I showed you, the fraction makes it be decay. That means it gets smaller. On growth, it goes up to the right. On decay, it goes down to the right. So you can grab it on your calculator, no problemo. We go to our calculator, and then we're going to change that e. We're going to insert parentheses. Always put parentheses around your fraction. And we have 1/4. Whoops. Delete everything because I goofed up. 1/4 raised to the x power, right? All there is to it. 1/4 raised to the x power. That's what we're graphing. That's what that says. Look what it looks like. It goes downhill. Pew! Has the same asymptote though. So it's going from left to right, going downhill the whole time. So where's the asymptote? Same exact place. The asymptote doesn't change. So I know D was the asymptote. And so that is y equals 0. Right? Now then, the x-intercept is the same also, because we're doing 1/4 to the 0 power, right? To find the y-intercept. To find the y-intercept. Wrong color. To find the y-intercept, all I have to do is plug 0 in. And when I put 0 right there, anything to the 0 power is 1. So this is actually 0. What does that say? What happened to my eraser? Okay, so Let's just say 0, 1. And of course, the x-intercept, there is none, because there's an asymptote. Say none, 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 none. And then where is this thing increasing? It's never increasing. Look at it. It's going downhill the whole time. If I was driving my car on this blue road, I'd be going downhill. Never increasing. Never, never, never. What's the range? Well, there are no negative numbers in the picture, none at all. So the range is everything greater than 0. And the domain is all real numbers still, because I can pick any x number. I can put negative numbers as an exponent. I can put positive numbers as an exponent, fractions, decimals, everything works. So that is that. Now, if you wrote down the other one, you'll notice that the domain's the same, and the range is the same, and the asymptote's the same, and the intercepts are the same. Everything's the same except increasing and decreasing. Because when you're going downhill, it's not increasing. If you're going uphill, it's increasing. So that's that. So now let's do one where we add and subtract, move things up or down, or left and right. You know, that's what we want to be sure we can do. So let's clean this one out. And I think we can do that one right here. So here we go. Now I'm adding inside the parentheses. So if you look at that little sheet, remember you got it in your Teams folder. If you look at that little sheet, this moves things to the left. L. That's supposed to be an L. Let's just scribble it. All right, so we're going to say left. L-E-F-T. It moves everything to the left. What are we moving to the left? Right? The asymptote doesn't change because there's nothing added. You know, we're saying +0 here. So the asymptote doesn't change. There's a dotted line right here. So what did I move to the left? Well, remember, the original one has a point at 0, 1. So here, let's figure out the original one. Let's just do y equals 2 to the x, right? So if I was picking numbers, if I pick 0, I know it's 1. If I pick 2 to the 1 power is 2. 2 to the 2 power is 4. 2 to the 3 power is 8. 2 to the 4 power is 16, right? We have that list of exponents. We know what they are. 2 to the -1 power would be 1/2, right? So what am I doing? This is the normal graph, right? The normal graph looks like this. It has a dot at 1, and then another dot at 2, then another dot at 4, then another dot at 8, and it goes, and one over here at 1/2. It goes like this, up, 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 right? But we're taking this point right here. We're taking every point and moving it 3 to the left. So let's go 1, 2, 3. Maybe I should put the little marks here. 1, 2, 3 to the left. Okay. So if I move 3 to the left, I'm going to move this point 3 to the left. So instead of being at 1, here, let's make this 1. Also 1, 2, 3. Okay. So instead of being right here, whoops, I moved my asymptote. There we go. Instead of being right here, it's going to be right here. And then this one is going to be at 2, and this one's going to be at 4. Whoops, didn't put enough marks. 1, 2. Ah. There we go. And then, so this one's at 4. This one's at 8. Right? It used to be over here, 1, 2, 3, 3, 8. But I move it 3 over, and so that's the intercept. And then the next one is 16, way up here. Okay? Way up here. So my graph, where's my blue color? There we go. My graph looks like this. How about that? Now what's the domain? Well, the domain didn't change. I just slide it sideways, right? I just slide the whole thing sideways. The domain stays exactly the same. What about the range? Well, the range stays the same too, because there is no negative number. Every answer that I get is bigger than 0. Okay. Whereas it increases, it's still increasing on the whole domain. Every number you pick makes it go uphill. No problem. What is the asymptote? The still y equals 0. Nothing changed. Nothing changed. No, that's not true, because the y-intercept changed, right? The y-intercept, when I put 0 into my problem, I'm putting 0 right here, I really get 0 plus 3. I get 2 to the 3rd power. 8 is the y-intercept. There's still no x-intercept. None, 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 none. Right? No x-intercept. None. Right? So the x-intercept, there is none. Okay. So let's do one where we have to slide it up or slide it down. Right? So let's do this one. Let's do this one. Got a different one here. Oh, there it is. Okay, so here there's nothing added in the end. Remember, there's nothing added to the x. This is the k value. This is the k value. So that's moving it down, right? Nothing is moving it sideways. So if I have the normal graph, oh, I wish I hadn't erased everything. If I had the normal graph, y equals 2 to the x, we still have all these values, 1, 2, and this is going to be 1 and 2 and 4, 8, right? And my graph looked like this. Where's my blue? Right? But the asymptote was right here on this line. So all that this -4 does, what does the -4 do for you? It moves the asymptote down. So now the asymptote is at -4. So y equals -4 is the asymptote of the problem. That 2 is the asymptote. E wants the asymptote, right? The equation of the asymptote, that's part E. I'm looking right here. If you're not looking where I'm looking, oops. Right here, I'm looking at the equation of the asymptote. That's E. So the equation of the asymptote is now -4. What? Yeah. Why is it that? Because this guy, can I slide it so you can see everything? Yeah. Because this guy right here just moves it down. We're not moving it sideways at all. So that means that the graph now is 4 lower than it was before. 4 points lower, right? So when I put 3 in, I don't get 8. When I put 3 in, I get 4. So 1, 2, 3. I'd be up here. This is 1, 2, 3, 4. be up here at 4. And then when I put 2 in, I would be 4 lower than that. So 2 would be the x-intercept, right? And then when I put 1 in there, I'd be at -2. 1, 2. And then 3 would be my y-intercept. And then remember 4 is where the asymptote is. So there's an asymptote at 4. And so my new graph, let's use a different color for my new graph. My new graph would look like this. Totally different than the original graph, right? So everything is down 4. So what's the y-intercept? The y-intercept is -3. What's the x-intercept? So this time it has an x-intercept because the asymptote's way down here. The x-intercept is 2, 0. And now the range is different as well. It's everything above 0, above -4. And then the domain is the only thing that didn't change. Still infinitely wide, always infinitely wide. The only thing different is the asymptote, right? That's the only thing that changed. It changed everything here, right? That made all of these change. When you change the asymptote, when I slide the asymptote down, then the domain's the only thing that stayed the same. Everything else changed. Everything else moved down. Remember, this is the normal graph. And then the new graph is down 4 from the normal graph. Okay, that's that. Oh, you should be able to graph today's homework without any trouble. And I say bye.